Hi, hello everyone. Welcome back to ANR Academy. This is Nepal Reddy sir. Today we are going to discuss how to integrate the functions e power ax multiplied by sin bx and e power ax multiplied by cos bx without using integral uv rule. Integration of uv I am not going to use to prove this result. Let us discuss the proof with complex numbers. Here, in case of integration of uv, you have to select first function as u, second function as v, and the rule u integral v dx minus integral d by dx of u integral v dx whole dx. With the help of this, we can integrate these two functions, and we know that the results are difficult to remember, and let us observe these two results. There is a common multiple e power ax by a square plus b square for both, and its multiple combination of two trigonometric functions. And observe the first term a multiplied by sin bx you have here. Next, a cos bx, a multiplied by cos bx, that you have here. And in case of uv rule, in the result, if you observe, you have negative sign in between two terms, and you will get u in the first term, its derivative in the next term. Here, first function u sin bx, its derivative must be in the second term, so that you have here b into cos bx along with negative sign. Next, here u is cos bx, its derivative b sin bx along with negative sign, cos bx derivative minus b sin bx, and one more minus is there, so that you will get plus sign. You can easily remember first term a sin bx here, a cos bx here. Next, remember sin bx derivative, that is b cos bx. In between the two terms, here you have negative sign, so that put negative sign. Next, cos bx derivative, that is minus b sin bx, one more minus is there, so put plus sign. So in this way you can easily remember the result of integration of e power ax sin bx, integration of e power ax cos bx. Let us see the proof with the help of complex numbers. Suppose that if I select I1, that is integration of e power ax cos bx dx, and suppose that I2 integration of e power ax sin bx dx. To the second integral I2, I am going to multiply iota here and here. This is first integral and this is second integral. Now adding these two, this is I1 plus iota I2. Next, integral. From both the functions, you may take common e power ax, so that it is e power ax common multiple, and inside we get cos bx plus I sin bx. Our aim is to find I1 and I2 just by comparing real part and imaginary part in the right side. Automatically that gives I1, I2 results. And now observe I1 plus iota I2 become integral e power ax. We know that cos theta plus I sin theta, that can be written as e power I theta, that is known as Euler form of complex number. We know that e power I theta, that is cos theta plus I sin theta. So using Euler form, I can change cos bx plus I sin bx as e power I bx dx. Now it reduces to the form integral e power a plus ib of x dx. You know that integration of e power ax. Suppose if you have integral e power ax, the result is 1 by a e power ax plus some constant. Using this result, here I can write 1 by a plus ib constant here, coefficient of x. Next, given function e power a plus ib of x plus some constant. In the next step, I am going to write I1 plus iota of I2, that is equal to, you have here 1 by a plus ib, 1 by a plus ib as it is. Next, e power a plus ibx, you have e power ax e power I bx. A power m plus n model, you have a power m plus n written as a power m into a power n plus integral constant. Just what I am doing, observe in the right side. If you rationalize this, that is multiply and divide with a minus ib. This is e power ax multiplied by cos bx plus I sin bx. In the denominator part, you have a complex number and its conjugate. So z into z conjugate written as mod z whole square. Therefore, I1 plus iota of I2 become numerator a minus ib, denominator part product of complex number with its conjugate gives mod z whole square. Mod z whole square value from this a square plus b square. And the next part I am going to write e power ax cos bx plus I sin bx plus some constant. Now just compare real part and imaginary part, then you will get the value of I1 as well as I2. First I am going to write real part and then I am going to compare imaginary part. Comparing real part, left side you have I1, imaginary part, that is I2. See the value of I1. Only the real part I am going to write. Here you have e power ax cos bx real, that is multiplied by a into a divided by a square plus b square. First, e power ax by a square plus b square separately I am going to write. Here you have real part e power ax and here in the denominator part a square plus b square. Next, only the real part a into cos bx. Next, minus ib multiplied by I sin bx. I into I square value minus 1. And one more minus is there. So plus b sin bx That is the result. Next, comparing only the imaginary part. E power ax by a square plus b square common. Only the imaginary part if you write. Here it is of minus ib cos bx. So imaginary part minus b cos bx. Next imaginary part a multiplied by I sin bx. I into a into sin bx. So imaginary part a sin bx plus c integral constants. So now this is I1. I1 is clearly e power ax cos bx integral value. So this is integral e power ax cos bx dx, and this is clearly e power ax sin bx dx. So this is the way to find integral value of the function e power ax sin bx, e power ax cos bx without using UV rule, just by using complex numbers. And now let us see examples based on this. Suppose the question, if you have find integral e power 2x cos 3x dx is there. You know that e power ax by a square plus b square is common for both e power ax sin bx as well as e power ax cos bx. So common multiple completed. Next, the first term you can write from the question, that is 2 times of cos 3x. Next, you have to write the derivative of cos 3x. Cos 3x derivative 3 sin 3x. When you have cosine function here, c indicates combination, that you have to remember, plus c. This is your answer. So in this way you can directly write the result. Next, suppose the question, if you have integral 3 power x sin 4x dx is the question. In place of e power x, given that 3 power x, I can write 3 power x as e power log of 3 power x multiple sin 4x. Exponential logarithm gets cancelled. Again we get only the exponential term 3 power x. Now it looks like e power. It can be written as x into log 3. Log 3 constant multiple x sin 4x dx. Now you can apply the formula integral e power ax sin bx dx. E power log 3 multiplied by x divided by a square plus b square, here log 3 whole square plus 16. Next, the first term from the question itself, log 3 multiplied by sin 4x. Due to sine function, remember minus sign here, subtraction symbol. Next, sin 4x derivative 4 cos 4x plus c. So this is your answer. Just remember the formula e power ax sin bx dx, e power ax cos bx integral values. Wherever the function sign, there you have to remember here negative sign. For cos, here you have to use positive sign. Okay. So in this way you can easily remember the results, and the proof here with the help of complex numbers by Euler form. Cos theta plus I sin theta changes to e power I theta, and automatically without using UV rule, after writing Euler form, the function converted into a single term as exponential function. You can easily write integral value of exponential function. So without using UV rule, just by Euler form, we are going to convert into a single term as e power a plus ib of x, then we can easily integrate. After integration, just by comparing real part and imaginary part, you will get the results. And the way of remembering the results is e power ax by a square plus b square, that is common for both the results. And the first term from the question, a cos bx, a sin bx, that you have to write. And for cos, here combination, and for sin you have to remember negative sign. Cos bx derivative actually minus b sin bx. So opposite to this you will get b sin bx. And if you have sin bx in the question, remember that here you have to write opposite function, that is co-function b cos bx. So I hope you understand everything. The students, those who are preparing for JEE Mains examination, please follow my channel. Please subscribe, like and share this channel. Thank you so much.